Congratulations and welcome on stage for this talk about both your personal and your scientific challenges during your careers and the innovative solutions which led to the development of mRNA vaccine technology and the first worldwide COVID-19 vaccine. My name is Morten Busch, and I will try to take you on this journey through these 4 fantastic prize recipients' career and into the future of medicine seen through the eyes of them. So, Ur, I know you love to spend your Friday evenings reading new scientific papers. In January 2020, in the Lancet, there was an article about a new coronavirus from China. This was before the pandemic was a reality. But what was it you realized when you read this article?
Yeah, this was the first scientific article published about this outbreak. And the article was describing a family traveling to Wuhan and traveling back home, and the family members got infected in Wuhan, and several family members went back and infected other family members. So it described the disease. It was a severe disease, and one important piece of information, which was almost hidden in the paper, was that one family member had asymptomatic disease. So he was virus positive with PCR, but did not have symptoms. And when I read that, this became not only an interesting article, but an extremely concerning article. It was very clear that people could travel as asymptomatic carriers who can spread the virus. And I had this picture that people would travel from Wuhan. I learned after doing the research that Wuhan is a mega city with a large international airport, 2,700 flights a week. Yeah? And I saw how this virus is like a metastasis spreading worldwide, and understood that this is already a pre-pandemic situation.
Özlem, together with Ur, with whom you have co-founded BioNTech, you decided to pivot a significant part of your company's resources from an ongoing cancer vaccine development to develop a vaccine against the virus. And you gave the project a special name. Please share your thoughts about this name.
Yes, so on that fateful weekend in January 2020, when we understood that we are already in the midst of a pandemic, we did not know how fast this pandemic would ramp up. Would it be only a few months so that no one would be even capable of generating a vaccine before mankind would be decimated? But what we knew was it had to be fast, the development of a vaccine, and therefore we called this project Lightspeed, because we wanted to make clear, and this was our pledge, that we would only accept limitations which were behind the laws of nature or the laws of physics.
Yeah, amazing. The resulting vaccine created faith that there was light at the end of the pandemic tunnel. But the fantastic speed of development also created some distrust in the safety of the vaccine. Drew, I could imagine that this skepticism must have been a bit frustrating to you, as the development of mRNA vaccine technology has had a somewhat different time horizon. Please share your thoughts on that.
So the frustration was really on multiple levels. The first is that people would say, oh, the vaccine was invented in 10 months, which is far from the truth. People had been using RNA and injecting RNA vaccines into people for over 20 years. So this wasn't a brand new development. The frustration went further, where people would say, I don't trust it because I don't believe in scientists and I don't think they have our best interest at heart. And that was really striking to me, because never before in my life as a clinician or a physician had somebody said, I don't trust you. I don't believe you're treating me with respect, or you're treating me correctly. So there was a lot of levels of just hitting to the soul with people's distrust in the vaccine. And that was disheartening. And I had to spend a lot of time trying to talk to people and explain to them how safe, how effective the vaccine was, and they needed to take it.
Today, mRNA therapy is considered to be extremely promising, but just a few years ago, many considered the technology unpromising. I brought this teddy bear. To the audience, this teddy bear is probably connected to something cozy, comfortable, a happy childhood. But to you, Katalin, it's also a symbol of a time when people might have believed less in your ideas. Please take us back to where it all started, back to Hungary.
Yes. So in 1985, I lost my position in Hungary in a biological research center where I was working with RNA, tried to develop an antiviral compound, and I tried to find a new challenge and try in Europe, because I like to be in Hungary. I never wanted to go to America, but eventually we had to go, and at that time, behind the Iron Curtain, we were allowed with my daughter $50, my husband $50, and me $0 to take out from Hungary. So we had a teddy bear, my daughter, who's here. She was just 2.5 years old, and I cut up the back of the bear, and I put there 800 British pound, and I sew it back, and I give it to her, and we, in the airport, everywhere we went, we watch out for Susan and the bear to make sure. So this is how we started our life in America. And we still have the bear.
Originally, Katalin started out working with DNA templates, but to get the human body to produce medicine against disease. But soon, DNA was replaced by RNA. Why was that?
So in 1990, the Human Genomes Project started in the United States, and most of the people, as new genes were discovered, that they are responsible for different diseases, everybody focused on DNA. But there are very, very few people, started to work with RNA, and I like the idea to use messenger RNA because it could be delivered inside the cell and it can instantly translate. And I envisioned first that, when we use cells and we could, introducing the protein, we could have a favorable characteristic of the cell. Maybe it would be good for cell therapy. And later, when it was injected animals, I was thinking that it will be good for human.
But not many people believed in your ideas.
That was important for me that at least one person, because I needed financial support. I could not ever get an R01 in my life in the United States. And I was left when I was 58 years old, so I never get a grant, never get my own money, but somebody, first in cardiology, then in neurosurgery, were supported, and sometimes Drew, you also supported my salary just to make sure that I can do the experiments.
Yeah, so there were only a few people along the way who believed in your vision for mRNA therapy, but then in 1998, you had a chance meeting with someone, and that changed your career forever. Please tell us about this meeting.
So we used to copy the articles, the scientific articles, on a Xerox machine or whatever copy machine we had. And in 2002, every paper I downloaded digitally. So if it would be a little bit later, I wouldn't meet Drew. But luckily, we didn't have digital version of the articles. We had to copy it. And I work in neurosurgery, but I keep going back to Department of Medicine because I know the password for the Xerox machine. So I so I met there the new guy who I like to brag, just I said my daughter is here, now I brag him about that I can make RNA, and you can see that Drew is...
that guy was you, Drew. And you soon realized that you shared a common interest with Katalin.
So we shared a lot of things. I think the main thing is we were both curious and open-minded and wanted to learn and wanted to understand. I was an immunologist, I am an immunologist, and who was interested in vaccines. And it struck me to make a good vaccine, RNA could be a great way to do that. So it was chance that I met Katie, but it set up a great collaboration where Katie would make the RNA, I would give it to dendritic cells to make vaccines, and that led to 25 years of collaboration.
And still good relation.
So maybe just a little bit about the dendritic cells, because on the surface of dendritic cells, that's where other immune cells can see these wanted posters you saw on the video to find out which villains are in town and which villains to kill. So these cells are key in vaccinations. And so in your early work with Katalin, you tried to target these cells to make them fight HIV. With success, or should I say, only you, Drew, thought it was a success.
Well, so we wanted to make a vaccine, and I had come from Tony Fauci's lab where I did HIV work. So, of course, I made an HIV vaccine. And Katie made the RNA for an HIV antigen. I added it to the dendritic cells, went back and looked at them a few hours later, and said, oh my God, these cells are activated. And back then, there was no reason to think that RNA would activate a cell. The cells are full of RNA, but for some reason, the RNA was highly inflammatory. It turned out that made a great vaccine response, but Katie became despondent because she wanted to use RNA to treat neurologic diseases, and inflammation in the brain don't mix well together.
And you, Katalin, you thought differently. You were not as happy as Drew, but then again, it also meant you took the next step.
Yeah, so I was not happy at all because I was in a neurosurgery, want to treat a stroke patient, with the final goal, and the inflammatory molecule would be detrimental. And so we started to ask the question, why? I thought that the RNA is identical and whatever inside the cell, but we thought that maybe because it's coming from outside from the immune cells, maybe even our own cells, if we would take out from our body, and put it to the immune cells, maybe it will be also cause inflammation. So that's why we set out to understand why it is inflammatory. And when we realized that one type of RNA was not inflammatory, tried to make it the messenger RNA non-inflammatory, and as the end of it, we could make RNA which contains pseudouridine, and it was translated 10 times better, and it was non-inflammatory. I mean, icing on the cake, all of these extra things, and we just couldn't believe. And I was happy that I can make mRNA for therapeutic purposes. And actually, that's my role also at BioNTech. I am responsible for the mRNA-based therapeutic protein production.
Yeah, so the pathway was now clear for you to start to throw yourself into developing both mRNA vaccines and treatments, and you created a spin-out company, RNA-RX, but something went wrong.
Yes, the university. I had already at that time was demoted and other things happened, and I was happy to go out, finally leave university behind me, but they did not give us our patent, so we could not, So
you didn't get a license to your own invention?
Yeah, for our own company. So so that I stayed.
But you know, when one door closes, another one opens.
Exactly. So
And that door opened when you were invited, Katalin, to give a lecture in Mainz. Why the invitation?
Yeah, I was following Katie's and Drew's work. We were a small community, and there were not many people publishing, and I had sent an email to Katie, I think 3 or 4 years before we met, and congratulated her on her publication. And she wrote me, "I'm following your work," yeah, and congratulations back. So she came to Germany. It was connected by a friend, and we started to discuss. We had dinner together after the seminar. The seminar was interesting, but what was more important, it was the dinner thereafter. Yeah, so we started to discuss, and I realized she is as passionate as we are. Yeah, and she's not only a scientist working on interesting things, but she has the same values, and this is really important. Yeah, so I asked her at the end of the discussion, Katie, do you want to join us? And she said, yes, why not?
Uwe's family is from Turkey, but they moved to Germany when he was just 4 years old. As a young boy, he loved to spend his weekends going to the Catholic Church library to read scientific books. But can you tell us, how was your interest in cancer and the immune system sparked?
So I was relatively early interested in the immune system because it's really complex, and I was always thinking about how this complex system of cells interact with each other. And there were first scientific articles. We have a German version of Scientific American, yeah, and I was following that, and this was really exciting. And when I was in high school, one of our family members got cancer. And I thought there must be better ways in treating them because it I heard as a kid the family member will die, and I had the feeling no one is doing something. Why are they not more active? And decided to do research.
So you trained as a doctor, and you got a job at Saarland, and that's where you met Özlem, right?
Yes, yes, absolutely. So I started in the University of Cologne, and then I wanted to go into the United States, but made just a short stop in the University of Saarland to go to the United States, and this short stop became very
lifelong.
Özlem also grew up in Germany as the daughter of a biologist and a doctor from Turkey. However, it was the nuns at your father's hospital who inspired you. Please enlighten us on this.
My dad, when he came from Turkey, he was sent to a place where German doctors did not like to go, somewhere in a sort of agricultural area, and there was a hospital which was a repurposed convent or monastery, and all the positions were done by nuns, and he was the only doctor and male person there who was treating the patients. And I saw him treating patients in a very patient-centric way, and the nuns the same. Yeah, and that was very inspiring to see that you can do something good by treating patients, by consolidating them, consoling them, and that was the inspiring part. Plus the fact that my father was very interested in ongoing science in order to provide the best for his patients.
And you then moved into science. So you started out both as physicians, then you moved into science, and then in 2001 you became entrepreneurs. So you started your own company. Why?
Yes, so we became entrepreneurs out of desperation. We were physician scientists, and our vision back there was that we wanted to bring our science, that we wanted to translate it to survival, to health, to cure. That was the overarching vision. And we found out that by treating patients by day and doing research by night, we would never be able to translate this to something meaningful which would up in a sustainable way at the patient's bedside. We understood that there has to be a path of drug development, and that this could only happen in a company where the funding and the structures and the processes would build the framework for a sustained development. And luckily, at that time, we did not know what that meant. And we founded the company, a venture capital funded company. Some of you may know what that means in terms of pain. But we, in retrospect, that was the right thing to do.
Yeah. So you developed many different technologies, and one of them was mRNA therapy. And as Drew and Katalin, you also had challenges, and one of the big challenges was the stability and the production of stability of mRNA, of course, and the production of protein resulting from it. But then in 2006, you got a big breakthrough, which led to the creation of BioNTech, and also you actually managed to convince a private investor of your vision.
Yes, so we were working on this idea, bringing mRNA from outside of the cell into the cell, and we realized that the cells were really producing the protein, but it was way too small. So, and we calculated that the immune response that we got from this is 100 to 1,000-fold lower than we need. So we asked the question, how can we increase that? Because the mRNA, if it goes into the cell, it has to compete with all the other mRNA. So it's a few mRNAs reaching the cell, but there are thousands of mRNAs in the cell. And what we recognize is that by modifying the parts of the mRNA outside of the message, these are called, for example, the untranslated regions, the 5' cap, the poly-A tail, these are elements. So we started to work with them and exchange that, and we learned that certain exchanges, certain modifications resulted in improvements. So these improvements were initially modest, 3-fold, 5-fold. But what we learned, and this was the exciting finding, is when we combined them, we got a multiplication, an exponential improvement. So 3-fold here, 5-fold here, 7-fold here, ended up in 100, 200-fold improvement of translation. And with this, we recognized now we can use much lower amounts of mRNA to get the same amount of immune response or even stronger. And we presented the data in a German competition, and evolved as winners. And there was one important task in this competition. You have to start a company 2 years after you you receive the funding. So we had to start our second company.
Yeah, and you managed to get a huge private investor, the Stringman brothers. Is that correctly pronounced? And then after you met in 2013, you joined forces, and it soon became obvious that despite working on different continents at approximately the same time, you found solutions to the same problems, but in different ways. So joining forces was a good idea. One of the major challenges remaining was getting the mRNA to the right cells in the body. And Drew, again, you found different solutions to the same problem. How did you solve that problem, and how did it?
So what we did was essentially a fishing expedition. So what we did is we looked at every formulation, every kind of lipid, sugar, protein that people had ever used to deliver a nucleic acid. And we tried it. And we kept looking, and we must have looked at 40 or 50 different formulations, trying to see which was the best, which ones didn't make the mice sick. And then lipid nanoparticles were identified. And both Katie and I spent 7 years trying to get them with no success. We finally got them around 2013, and we tried them, and they were beautiful, made huge amounts of protein, and the animals didn't even notice they received it. So that was kind of the turning point for delivering RNA as a therapeutic and as a vaccine.
And already in 2014, you did your first patient trials with using individualized mRNA therapy against cancer, and you did participate in trials. I think it was Zika virus, right?
Yes, so that was 2017.
Yeah, okay. And the success of these trials actually made you come up with a quite extraordinary statement at a conference in Berlin in 2018.
Yes, I was invited to give a keynote talk in Berlin in an infectious disease conference, and I said, actually, I'm doing cancer research, and I gave a talk about personalized cancer vaccines, and these personalized cancer vaccines are prepared in an individual manner. So that means we get the tumor sample from the patient, and then we sequence the tumor, we identify the antigens, we create the vaccine and then deliver it back to patients. And we manage at that time to reduce this vaccine preparation to less than 6 weeks. Yeah? And since I was on this infectious disease conference, I said, by the way, this is about cancer, but this rapid process of making a vaccine, yeah, could be also useful in an outbreak situation, yeah, to deal with a rapid pandemic response. Yeah? And this was meant seriously, but of course the likelihood that this is going to happen 2 years later was extremely small.
Yeah, because less than a year later, after that statement, the first reports of the new coronavirus from China ticked in. And after you had convinced your board at BioNTech to react, you also had to convince a larger biotech company to take part in, because BioNTech at that time did not have the muscles to manufacture a vaccine. So you had to convince a larger biotech company. Please.
Yes, these are the colleagues from Pfizer, and we were already working with Pfizer for more than 1 year at that time. And I called a colleague, Weissman, who is an extraordinary scientist, and Phil Dormitzer.
You are also excited.
See. So Phil Dormitzer, who is an extraordinary infectious disease expert, and as I said, we are developing a vaccine because we believe this will become a pandemic. Is Pfizer interested to join us? And he said, no. So first of all, we don't believe that this will become a pandemic. And the second is there is no example that a vaccine has ever been developed and reached the people during a pandemic. Yeah? And he was right. He was absolutely right as an expert. So
still, when you got home, you said something to Özlem.
Yes, that we will call him a few weeks later.
And you did.
Yes, we did. But this time I called Katrin Jansen, and she was his boss. Yes, and then she said, without letting me continue my sentence, is Pfizer interested? She said, of course, let's start.
In this book about the vaccine, the intense development of the COVID-19 vaccine, it's obvious that there are many keys to the success of the development. And we don't have time for all of them, Özlem. If you were to highlight a few keys to how you managed to make this vaccine at Lightspeed, what would those be?
Two things of many. One is all those years of effort and investment and discoveries and findings and building of knowledge. They were important, and they were the foundation. And the second was that there was already a team which had gone through roller coaster times together, which could be mobilized and aligned in a way that we could do things fast, at risk, in parallel manner.
So 9 months later, in December 2020, the results of the phase 3 trials of this vaccine were published, and the vaccine was 95% efficient against COVID-19. Katalin, I know your reaction to this was very interesting. What was your reaction when you heard the results?
Actually, it was November 8th.
Okay.
I know, because my daughter's birthday, and we celebrated with my husband. And then Ugur called me and asked me that whether I am alone in the room or somebody is listening. That's what anyway, and then Ugur told me that how well it performed, and the vaccine, and then I told my husband, and it works. I thought so, and because maybe I am not a vaccinologist, not an expert, so maybe that's, for me, that's what I expected. But based on what we have already together with all of you, you know, what experience we had with the different viruses, the Zika, the influenza and others, and as well as the clinical trial, that I was so confident that it will work. And
So you were not surprised?
No.
In 1 year, 10 billion COVID-19 vaccinations were carried out, and in November 2021, WHO estimated that the vaccine had saved 500,000 lives directly. A vaccine against the new Omicron variant has already been manufactured. And I'm not sure if you brought one of the vials, but I also know you think it's a bit too early to say whether the pandemic is over or not. So I'm not going to ask that question because you promised me a boring answer. So instead, I will ask all of you, what do you think young researchers, innovators, funding foundations can learn from this story about developing new technologies, treatments, and how to test them? Drew?
So you're asking an old dog to learn a new trick, which is always difficult. Looking for innovation in life and in science, to me, is critical. And I think that's what was missed here, is that the original funders didn't like RNA because it was tough to work with. They didn't look at what the capacity is. And that's what kept Katie and I going. So I think it's important to look at the innovation, to look at the potential before you grade, should I fund this project or not?
Any comments here?
Yeah, I think I agree with the key aspect. So if you phrase it in a different way, if you can't find a reason based on a physics law, and if it's doable, just ask the question, what would be the potential? And if the potential is great, and if physics would allow us to do it, then just try it.
And how do you think mRNA therapy will develop and change the future of medicine?
mRNA has a transformative potential. We like to compare it a bit with advent of recombinant protein technology. Prior to that, you had to extract hormones for medicines from animal organs and so on. And all of a sudden, you had this technology where you could stick a plasmid into a cell and grow this cell in fermenters and produce proteins recombinantly. And now with mRNA, you can basically ditch the middleman, and you can put the mRNA into the patient's or the individual's body to treat, and thereby deliver the information you want to deliver. So we think it is transformative because it is a paradigm, a concept, which can be very broadly used for anything which nowadays is being treated with protein, with recombinant proteins and beyond.
So what I could say, the young one, is that, just like us, believing in ourselves, believing in the science we are doing, working together, that's what I would say.
And Drew, I know you are developing a lot of different therapies with mRNA, right?
I mean, the potential is enormous. And Katie and I, 25 years ago, would sit down and just list all of the things that RNA could do. And now we're seeing many of those being done. There's just so many diseases, so many genetic deficiencies, genetic conditions, acute and chronic therapies. It's really unbelievable.
So that was the last question we had time for. I would like to thank our 4 fantastic prize recipients for sharing a story about how dedication, perseverance, and reactivity can turn an impossible mission into a revolutionizing vaccine. The beginning of the end of the pandemic, I would say. So please join me in giving a very big hand to Katalin Karikó, Drew Weissman, Ur Shahin, and Özlem Türeci. Now, Jørgen Frøkjær, Chairman Jørgen Frøkjær, will come to the stage and hand you the 2022 Novo Nordisk Prize. Congratulations and thank you.
Well, thank you very much, Morten. First of all, I think we should give another hand to Katalin Karikó for... Please. And Drew Weissman, congratulations. Özlem Türeci. And Ur Shahin. Wonderful. You're welcome.